Alrighty, everybody can see this now. Excellent, excellent, excellent. Good morning, Precalculus CP. Today is Wednesday, April 8th. What I would like to do today is review for the upcoming summative assessment. Hopefully the PA went okay. Yes, PA should have been clear. I think it's straightforward. I think it's on everything that we've talked about. So hopefully that wasn't much of an issue, the progress assessment. It was due as of a minute ago. So hopefully you were able to submit that to me via email. If you did not submit it, I was just telling Alejandro at the start of class here, I am going to look at grading them tomorrow morning. So if you really need until tonight to do it, like, I guess you can do it, but it really would have been appreciated if that's in at the start of class. But if you need that little bit of time, if you didn't get to submit it, make sure you please submit it tonight, so tomorrow I can go in and grade it. All right, that just gives me enough time too to provide you feedback as well. So that's really the big point of why I really want that submitted at the start of class. Okay, so hopefully it went okay though. I am going to, by the way, to provide you that feedback, I am going to post an answer key to the progress assessment on Google Classroom. Yes, you were supposed to email it. I got a lot of them, so I might be talking to no one when I said nobody completed it, but because I did receive a ton of submissions. But I am going to post an answer key to the progress assessment on Classroom. So that's another reason why I need you to submit it, because I can't post the answer key and then accept your submission. That doesn't make any sense. So make sure you do get that submitted to me. Hopefully you'll be able to see with your grade in Aspen plus the answer key side by side with your work why you may have received the grade that you did when those grades are entered tomorrow. But if you require more specific feedback, please make sure to reach out to me. I think that the answer key should be enough. Like, looking at the answer key and looking at your work, you'd be like, oh, that's where I made my mistake, and that's where Mr. Giorgio gave me credit or didn't give me credit for that particular thing. But if you still have a more specific question, if you're like, why did I get this grade, then please do not hesitate to reach out. I'll be happy to clarify anything. Okay? But that's what I'm going to do. So, without any further ado, I'd like to talk about the summative assessment. So our summative assessment is scheduled for April 14th. That is next Tuesday. Just making sure that date is right. Yep, April 14th. Okay. The way that it's going to work, much like the progress assessment, I am going to send you an email in the morning at 8 a.m. I'll have it scheduled to go out at 8 a.m. Attached with the progress assessment. There it is. Or the summative assessment, rather. Here it is. Here's the summative via email. It's going to be your job to complete it and send it back to me by 6 p.m. that day. Okay, so that's a big block of time. That's 8 a.m. to 6 p.m. That's 10 hours. That doesn't mean that it's a 10-hour assessment. It just means that it's a normal length summative, so it should take about an hour to do. But you're given that amount of time because, number one, you have other classes during the day, and number two, there's a lot of unforeseen and unexpected things that can happen at home, including distractions and tech problems and whatever. So I think that's more than fair to grant that window of time for you to get that done. Okay, so hopefully that ends up working out for you. But if you do have any concerns, please let me know in advance. Please don't say, I know sometimes things come up last minute, but don't be like, oh yeah, by the way, I can't do it. So please let me know in advance so we can work anything out ahead of time. All right, but that's the plan. Okay, that grade will go in as soon as possible, and that will be your last grade for the third quarter. Does anyone have the summative, by the way? What is it going to be on? It's going to be on your area of triangles, and it's going to be on your law of sines and law of cosines. Really, those three big topics. Of course, we've also talked about the area of irregular quadrilaterals. You can expect a problem like that on there. That's just an application of the area of triangles. We also saw problems like find the area of a regular hexagon, for example, or a regular octagon. Any of those types of problems can certainly be on there. We've seen problems like word problems involving law of cosines. That could be on there as well. So anything that we've talked about in this distance learning is fair game for that assessment. All right, but again, you do have all day to do it and get that submitted to me. Does anybody have any questions as to the structure of the summative assessment? No questions? Feeling good about it? It makes sense. What's expected? Everyone seems like that's a fair deal, right? That it has to be done that day. It's plenty of time, hopefully. So, feeling great. But if anybody does have a question, please feel free to reach out. If you don't feel comfortable saying it in front of everybody, that's fine. Just make sure you reach out. All right, so let's go through a couple problems together that really refresh the topics that are going to be featured on the summative. Starting with the area of triangles. So I'm just going to do a big review. Oh, by the way, I did also post a test review on Google Classroom, so if you didn't get a chance to see that yet, it is there under the distance learning tab there. It does have the answer key as well, so you can go ahead and refer to that too. So let's start with our area of triangles problems. Okay. Again, remember our formula to find the area of these triangles? We use that the area is equal to 1/2 AB sine C, where A and B represent two sides of a particular triangle, and C, angle C, is your included angle. That's a really important idea, that it's the included angle between both of those sides. Okay, so just a little quick example like this. If I said find the area, and this is how you find the area of things that aren't right triangles really easily. Right, here's a triangle. So we call this triangle DEF. I don't know why I wrote it backwards, but triangle DEF. I'll say this is 9.4 units this side. This side is equal to 7, and this side is equal to 59 degrees, and you're asked to find the area. Well, all you have to do is, again, just make use of your area formula, where I would have that my area is equal to 1/2 times one side, 9.4, times the other side, 7, times the sine of the included angle, so sine of 59 degrees, and you would go ahead and plug that into a calculator, which I'll do for you right now. There's a little crumbs on it. We got 0.5 times 9.4 times 7 times sine of 59, bang, and we get that our area is about 28.2 square units. Hopefully that makes sense to everybody, how we can apply that formula. Again, we saw a key application of that was the area of irregular quadrilaterals, which we did on Monday, where you can split your quadrilateral, your four-sided figure, into two triangles and find the area of both separately and add them together. Hopefully that makes sense, yes? You can also get problems, by the way, that go in reverse. So it can say something like the area of a triangle is something like 57 square units if one side is 13 units and the other side is 9 units. Find the possible measurements of the included angle. Included angle. Okay. So just basically asking you to go the other way, where it's saying, now I'm giving you the area, I'm giving you the sides, what's the angle? So if I did that, I would set up my formula by saying, well, my area is 57. And that's equal to 1/2 times one side, which is 13, times the other side, which is 9, times the sine of my included angle. Okay? Using our handy-dandy calculator, I'm going to go ahead and say, well, 0.5 times 13 times 9 comes out to be 58.5. So I have 57 would be equal to 58.5 sine of C. We have to divide both sides by 58.5 to get that sine of C by itself. So I'm going to do exactly that. I got 57 divided by 58.5. We get 0.97 is equal to the sine of C. That comes out to about 0.974. Yes, I just rounded. Now we can go ahead and apply the sine inverse on both sides to cancel out that sine. Just like that. And again, with my handy-dandy calculator, I would say, well, what is the sine inverse of 0.97? And we get that it's about, C is about 75.93 degrees. Okay? Or at least that's one possibility for angle C, because again, you may remember that the sine is positive in both the first and second quadrant. Right? Sine is positive up there and negative down there. So 75.93 represents my first quadrant possibility, where yes, my angle could be acute, it could be located in the first quadrant, but we also don't have enough information to rule out the second quadrant possibility to say, well, what if my angle is obtuse? It would have the same exact sine value, so we have to consider both cases where I could say angle C is 75.93, or to find the equivalent quadrant 2 case, I could say, well, angle C could be 180 degrees minus 75.93. And you would get the other possibility for angle C is 180 minus 75.93. You would also get that it could be 104.7. Okay, 104.07, sorry, 0.07. Okay, so both of those possibilities would have to be noted for something like angle C. Does anyone have a question as to how that's done at all? Okay, so you could say, based on the information provided, angle C could be 75.93 degrees, or it could be 104.07 degrees. Again, there's not enough information to rule out one possibility or the other, so we have to consider both. Okay. Speaking of considering both possibilities, let's take a look now at a law of sines problem, because you may remember that with a law of sines, we can get this thing referred to as the ambiguous case, where we have multiple possibilities for the angle of a triangle. I think it's definitely beneficial to show off another one of those problems now, and hopefully explain why that's the case again. So, what if I told you this? Solve triangle ABC. Again, when you see that terminology of solve the triangle, that just means find all the measures of all sides and angles. Where angle C is equal to 15 degrees, B is equal to 20, and C is equal to 12. Okay, so just to create a little quick sketch here, clearly not trying to draw to scale in any particular way. Say I have this is A, this is B, this is C. That means this is side A, this is side B, and this is side C, because they're always across from each other. This would mean that if this is 15 degrees, this is 20, and this is 12. Can I find the rest of the measurements of the triangle? And absolutely we can. We'd start with the law of sines. If you remember, the law of sines says that the sine of A over A is equal to the sine of B over B, which is also equal to the sine of C over C, right? That ratio is true amongst all of your sides and angles of the triangle, okay? So it's always good to start with things that are across from each other. And let's solve for this angle B, which is directly across from that side B, right? So we can start by saying, well, the sine of 15 degrees over 12 should equal the sine of angle B, which I don't know, over the side B, which is 20 rather. Okay. Little cross multiplying there, you would get 20 sine of 15 degrees is equal to 12 sine of B. Divide both sides by 12, you would get 20 sine of 15 degrees over 12 is equal to the sine of B. Let's have to apply a little sine inverse on both sides in order to get rid of the sine that's in front of B. So, handy dandy calculator again. We got the sine inverse of 20 sine of 15 degrees divided by 12. Bam. And we get that angle B could be 25.55 degrees. But there is another possibility for angle B as well, because this only represents the first quadrant possibility. There's another angle in the second quadrant that also shares that same sine value, because it would be the same vertical distance up from the x-axis. In order to find that quadrant 2 possibility, I just go ahead now and do 180 degrees minus my 25.55 degrees. And I would get that my quadrant 2 possibility, 180 minus 25.55, is 154.45 degrees. Okay, so B could also be that. Now at this point, remember, we kind of step back and we see, well, is that realistic? Is it realistic that we could have an angle of 25 degrees or an angle of 154.45? And in this case, both of them are. Remember that your triangle angles have to add to 180 degrees. So here I have my starting angle of 15 plus, if I use the acute case, 25.55. Right? That's well under our requirement of 180 degrees, so we could have this angle in there, no problem. if I have my starting angle of 15 plus my obtuse case, that's still under, not by much, but it's still under our 180 degree angle. So we could have an angle like that. Those are both realistic. It would not be realistic if I got something like, say, angle C was 60 degrees, and then I got an answer of 154. We clearly could not have that because that would well exceed our 180 allotment. Okay? So since we do have two possibilities here, we need to account for both cases. We need to account for the quadrant 1 case, in which, I'll try to draw this a little more accurately here. Angle C would be this really narrow angle. Angle B would also be kind of narrow, and angle A would be this kind of obtuse angle. So not the best triangle in the world, but it would look kind of like that, where C, B, and A, this is only 15 degrees, this is only 25.55 degrees, and you'd have this big angle here that we'd have to solve for, right? This would be 12, this would be 20. Okay? You could also have the quadrant 2 case. The quadrant 2 case is where B is this big obtuse angle. So we'd have our tiny angle C, we'd have our big angle B, and we'd have probably another really small angle A. So maybe something more like this. Like that. And this is our 15. And this would be our 12 and our 20. You do not have to draw them out. You don't have to draw pictures, but it does provide you a nice visual. If your artistic skills are a little better than mine, it provides you a nice visual. This provides an okay visual, but it gives you a little idea of what's going on. All right. Regardless, though, in both cases, we have to first solve for angle A, and then we can get the side across from A. You might look at that and you might be like, oh, it's a lot of work. It is a little more work, but like it's not really that much. We can solve for angle A by just doing 180 minus those two things. So 180 minus our 25.55 that we found minus our 15 starting means that angle A has to be 139.45, right? So just to write that out, angle A would be 180 minus 25.55 minus 15, which comes out to be 139.45. Okay, everybody sees that hopefully. Once you know that, we can use our law of sines to go ahead and find side A. Again, I always like to pair it up with the given information versus the approximate information that we did with angle B. So I'm going to pair it up with side C, and I'm going to say the sine of 15 degrees, which is angle C, over side C, which is 12, is equal to the sine of my angle A, 139.45, over side A, which I don't know. Okay, a little cross multiplying, I get A sine of 15 degrees equals 12 sine of 139.45. We can divide both sides by the sine of 15 to get A is 12 sine of 139.45 degrees over sine of 15 degrees. We can go ahead and plug that into a calculator. I'm going to get, let's see, 12 sine of 139.45 divided by sine of 15. We get that A is about 30.14. Which should definitely make sense because the largest side should be across from the largest angle, which is the case here. Note that it would not make sense to get an angle or to get a side measurement less than 20 because it's across from the obtuse angle, so that should never happen. Okay. Feeling good about that, hopefully? Feeling great. We just have to do the same thing with the quadrant 2 case. It's nice and quick. I can first find my angle A. I would say angle A is 180 degrees minus our 154.55 that we started with, or that we solved for, minus the 15 we solved with. Sorry, I'm all mixed up. That we started with. So 180 minus the 154.55 that we solved for, minus the 15 we started with. Jeez, I don't know why that sentence was so difficult. Jeepers. All right, here we go. Minus 15. And we get that angle A is about only 10.45 degrees. So since we now get an angle even smaller than C, that means that side A should be the smallest side. Let's go ahead and figure that out using law of sines. Again, I'll pair it up with C to say the sine of 15 degrees over 12 is equal to the sine of 10.45 degrees over side C. Cross multiply, C sine of 15 degrees equals 12 sine of 10.45 degrees. Divide both sides by sine of 15. We get C equals 12 sine of 10.45 over sine of 15. Plug that into a nice handy dandy calculator. We're going to get 12 sine of 10.45 divided by sine 15. We get that C is about 8.41. Oh, sorry, A. Why did I say? Did I label this as C the whole time? I did. It's A. Sorry, side A. Side A. Side A. We already know side C. Side C is 12. We're looking for side A right here, which would be 8.41. My fault. Again, my apologies. That should be side A. Side A, across from angle A. And that value makes sense, by the way, because, again, the shortest side is now across from the smallest angle. Okay? Any questions on that? Remember, again, with law of sines, you could potentially get two cases like you saw here. You could only get one case where this quadrant 2 angle doesn't make any sense, and so we just throw it away. Or you could actually get no solution if you get an error when you're trying to find this value here. That means that you try to find an angle that's bigger than 180 degrees. It doesn't make any sense, like a sine value greater than 1. Illogical. Illogical. Okay? Okay, last but not least, let's go to a law of cosines problem, just to show you that. Okay? So law of cosines problem is really used when it's still the same deal where we're trying to solve the triangle, but it's used when we don't start with something that's across from each other. So because it's a little longer of a formula, that's why it's preferable where if you could use the law of sines, then use the law of sines. But if you can't, then we got to go to cosines. All right, so start with a problem like this again. Solve triangle ABC. If we'll say B is 21, we'll say C is 17, and we'll say A is 29, starting with all three sides, right? So that means I have a triangle kind of like this. Here's my A, here's my B, here's my C. Again, not drawn to scale. I'll say this is 29, C is 17, B is 21, okay? Notice in a triangle like that, I don't have any information that corresponds to each other. I don't have angle B inside B. I don't have angle A inside A. I don't have anywhere to start with law of sines. So we have to use law of cosines to give ourselves that good starting point. In order to do that, the law of cosines formula, you may remember, is C squared equals A squared plus B squared minus 2AB cosine C. And the ABC can be flipped around. A couple people asked me that when they were doing the homework assignment on law of cosines, and they can be flipped around as long as these two match up, right? So say you wanted to solve for angle B, well then or side B, you'd say B squared equals A squared plus C squared minus 2AC cosine B. It's really these two that match up, and then these two are the other two sides and other two angles. Okay, other two sides, other two sides. It's these two that, it's like these are the ones I'm looking for. So when you're faced with one of these problems, it's always a good idea to look for the largest side first, so that way you can avoid any of that obtuse angle, ambiguous case stuff. In order to do that, I'm going to go ahead and solve for angle A first. So if I'm solving for angle A first, the way I'm going to set this up is A squared is equal to B squared plus C squared minus 2BC cosine A. See how I really just am now looking for these? So that's why these are the other two sides. Other two sides. Okay? Let's plug in what we know and solve for what we don't. I get 29 squared is equal to B squared is 21 squared plus C squared, 17 squared, minus 2 times B, which is 21, times C, which is 17, times cosine of A. And I don't know what that is. That's what I'm looking for. All right? Again, we refer to the calculator. 29 squared is 841. And that's equal to 21 squared, 441, I could probably do that in my head, plus 17 squared is 289, minus 2 times 21 times 17, so 714 cosine of A. Just combine like terms of the calculator. We're going to do 841. We're going to subtract 441 from both sides. We're then going to subtract 289 from both sides. And you get 111 equals negative 714 cosine of A. Divide both sides by negative 714. Oops, that's not the right button. I want to divide. Rats. I want to take the answer and divide by negative 714. And you get about negative 0.16 is equal to the cosine of A. Take the cosine inverse of that. So I'm going to do the cosine inverse of negative 0.16. And lo and behold, we get that angle A is about 99.2 degrees. Okay? Good. By finding that first, that ensures that we take care of that obtuse angle case. I now don't have to worry about, is it a quadrant 1, quadrant 2, quadrant whatever. Now we can just go ahead and solve for one of the others in a very straightforward way, and then subtract from 180 to get the last one. Okay? I think it's a good idea to solve for the smallest one next, so we're going to solve for this one right here. We can use our law of sines to do that now, because now I can say the sine of 99.2 degrees over 29 is equal to the sine of C, which I don't know, over 17. Little cross multiplying, I get 17 sine of 99.2 degrees equals 29 sine of C. Divide both sides by 29. 17 sine of 99.2 degrees over 29 equals sine of C. Take the sine inverse of both sides now, and I get the sine inverse of 17 sine 99.2 divided by 29. We get that angle C is about 35.36. Okay. And if we get that, now we can just solve for the final angle by subtracting from 180. So we know all three angles of the triangle total 180. I can subtract away angle A. I can subtract away angle C. And that should give me the result for angle B, which is 180. Sorry, the calculator is so dark down there. It's just a dark day outside. I don't have good lighting in here. Minus 99.2 minus 35.36. And that comes out to be that angle B is 45.44 degrees. Okay. Excellent. Excellent. And now we've solved for all the sides and angles of the triangle. Does anyone have any questions, comments, concerns about this at all? We're all feeling happy. We're all feeling fantastic. We got about a minute left. Does anybody have any lingering questions about what we're talking about now, the topics we're talking about now, about the assessment coming your way next week, about anything? David says all good. Anybody else? I take your silence as I am fully engaged and I completely understand the concepts of pre-calculus that you've taught me today. Excellent. Well, that's fantastic. Okay, so if you do have any other questions, though, please feel free to let me know. That's all I have for you guys today. Again, expect that summative email to be sent to you on April 14th in the morning. You'll have until 6 p.m. that day to get it done. Send it back. I think that's more than a reasonable amount of time. If there's any issues that you foresee prior to that, please contact me and let me know ahead of time. I know sometimes things happen last minute, but if we can squash any issues ahead of time, it's always beneficial to do so, right? So thank you again. I will see you on that Tuesday, and I hope you have a fantastic weekend because I won't see you before that. So have a great weekend, and enjoy. Good luck. Study hard. Answer key test reviews on Classroom. I know you can do it. I believe in you. I believe in you, pre-calculus. You got this. You got this.